Another day, another video, section 3.2, kind of going in order. Finish 3.1, move right to 3.2. How nice is this? Change of pace. I'm enjoying it. I hope you are. Today we're going to find the zero of a linear function. My hope is that after watching this video, you'll be able to find the zero of a given function written in function notation. That'll be the hard part. And then use that concept of a zero to solve word problems. Let's jump into it. Definition. A zero is just another word for the x-intercept. By the time we're done with Algebra 1, we're going to have 4 different ways of saying x-intercept. First one, or the second one, is 0. Okay. This name comes from the idea of it's the input for which y equals 0. And we plug 0 in for y when we find the x-intercept. So different name, same point on the graph, same way of finding it. We plug 0 in for y, and that's going to be our 0, just like it was our x-intercept in the previous video. Okay, it's found by plugging 0 in for y and then solving for x. So again, same process that we've already done, just a new name for it. All right. So if we have y equals negative 4x plus 28, if we want to find the 0 of that function, we just plug 0 in for y, same way we found the x-intercept. Where it'll be a little different is in this section, we give all the functions to you in function notation. So instead of it saying y equals negative 4x plus 28, it's going to say f of x equals negative 4x plus 28. Doesn't change a thing, because instead of plugging 0 in for y, you just plug 0 in for f of x. I even copy and pasted, like when I was making the slideshow, I didn't type that in again because it's the same thing. Nothing changes. We're just writing it a little bit differently. Again, function notation has uses when you get deeper into math. We have to learn how to use it so that when we get there, it's not like totally new. Okay, so we're going to practice with function notation in this section. We're still just plugging 0 in for f of x and solving. That's how we're going to find our 0, the x-intercept. Here's what the homework looks like. It says find the 0 of each linear function, and they'll give you a function like the one we just talked about. F of x equals negative 4x plus 28. How do you find the 0? Plug 0 in for f of x. Okay, replace that f of x with 0, and you get negative 4x plus 28 on the right side. So you're going to subtract 28 from both sides. Negative 28 equals negative 4x. You're going to divide both sides by negative 4, just like we've been doing, and you'll get negative 28 divided by negative 4 is positive 7, so x equals 7, which means the 0 of this function is 7, or x equals 7, if you want to be a little more thorough, which I always encourage. Okay, that's it. Okay, I'm not going to throw you any curveballs. We've got one more example, which I'm going to move my head out of the way for. And I want you guys to try this one, so pause the video. Try and find the 0 of this function. F of x equals negative 2/3 x plus 4. Good, hopefully you paused. Like I said, these problems start the same. Plug in 0 for x. Plug in 0 for y, which would be plug in 0 for f of x. That's where I got confused, pardon me. And then we're going to solve like normal. Subtract 4 from both sides. Okay. You'll notice we've got the fraction to take care of. So when I subtract 4 from both sides, I've got negative 2/3 x. How do we get rid of fractions? We multiply by the denominator. So multiply both sides by 3. That's where the negative 4 becomes a negative 12. Negative 4 times 3, negative 12. All we have left on this side then is the negative 2. Negative 2x, divide both sides by negative 2. Negative 12 divided by negative 2, positive 6, x equals 6. Okay? Same thing we did in the previous section, right? These first 6 problems in the homework are the exact, matter of fact, they're half the work from the previous section, because in the previous section you had to find the y and the x-intercept. Here it's just the x-intercept, because that's all find the 0 is. Find the x-intercept, okay? Now, there is a tricky example, but it's actually easier, okay? It's actually easier, okay? F of x equals 2, okay? Think for a minute, what's missing? There's no x on the right side. You're right, there's no x on the right side, but we still plug 0 in for x. I'm sorry, gosh, I keep saying it. There's still no 0, you still plug 0 in for y, okay? which means you still plug 0 in for f of x. So you get 0 equals 2. However, 0 does not equal 2, which means there is no 0. So we would say there's no solution. Now, what does this mean? Because this is weird, and this does show up on the homework, I think twice. We have f of x equals 2. We plug 0 in for f of x, but 0 doesn't equal 2, so we don't have an x-intercept. We don't have a 0. But if we think about this graph, here is the graph for f of x equals 2. Anytime you don't have the x value, you just get a horizontal line. F of x is always 2 no matter what the input is. So nothing is going to make it where the y is 0. It never crosses the x-axis, so there is no x-intercept. There is no 0. Not a problem. It's actually less work. Okay, so that's it. Plug 0 in for f of x instead of plugging 0 in for y. It's the same thing we've done before. Solve it. Tell me what you get for x. Okay, pause the video. Try the first 6. Plug 0 in for f of x, and then solve it and tell me what you get for your x-intercept, which would be tell me what your 0 is. Super Castlevania 4. It's a fun one. It's another game where you get to use a whip, but in this one you only get to use a whip. You also have some other knives and like potions and stuff you can throw, but it's pretty much all the whip. It's a lot of fun. You get to kill Dracula at the end with a whip. Apparently that was the secret. Castlevania, Super Castlevania 4. Move my head again. Let's go down here to start. Second half of this is word problems. Get excited. Enrique uses a gift card to buy coffee at a coffee shop. Extra info, we don't need it. The initial value of the gift card is $20. Turns out that's extra info too because the function n equals 20 minus 2.75c represents the amount of coffee still left on the gift card in after c cups of coffee are bought. Okay, that's the first real important bit of information, and there's a ton of it there. But when doing word problems, start with what the question is asking. Find the 0 of this function. We can do that. We know how to find the 0. Plug 0 in for y. Then describe what this value means in context. That will be trickier. Let's walk through this problem. There are really three really important things that I want to focus on. The first thing I want to focus on is this equation, and then describe what this value means in context. We've already talked about how to find the 0, but this equation, we said find the 0 of the function. We said plug 0 in for y, but there is no y. In fact, there's no x either. Yet coincidentally, I pointed at the n when I said there is no y, and I pointed at the c when I said there is no x, because n's working the same as y and c is working the same as x. If we think about it, n equals 20 minus 2.75c. It's very similar to slope-intercept form. We have some number, n, which in this case is the amount of money still left on the gift card, and it tells us there, okay? C cups of coffee, so every time he buys a cup of coffee, you take the $20 that started on the gift card minus $2.75 for every cup that you buy, okay? If you buy 1 cup, you subtract 2.75 times 1. You buy 2 cups, it's 2.75 times 2. You buy 4 cups, it's 2.75 times 4. So C, the number of cups you buy, that's your independent variable. That's your x. The amount of money that's left on the card, n, depends on how many cups of coffee you bought. Makes sense? Okay, if you go back to our input versus output discussion, input a certain number of cups of coffee, output a certain amount of money left on the gift card. Okay? And if you buy 0 cups, you got $20 still. That's your y-intercept. We need the x-intercept. We need the 0. So we are going to plug 0 in for n. Now I say all this explanation of independent and dependent variables to mathify the very simple fact that all the equations for these word problems are going to be some not y letter that fits the context of the word problem equals something, usually minus something else, times some other not x number, okay? It's always going to be in some version of slope-intercept form. So whatever letter's by itself here, just know that's going to be your y value that's what you're going to plug 0 in for, so you can find the 0 of this function. So in this case, we start off with n equals 20 minus 2.75c, and we're going to plug 0 in for y, plug 0 in for the dependent variable, and then we're going to solve like normal. So we plug the 0 in for y. We're going to subtract 20 from both sides, and I know I said I usually try and avoid negatives, but I found in this case, better just deal with the negatives than trying to add 2.75c to both sides. We'll just subtract 20 from both sides. We'll divide both sides by negative 2.75. And then it comes out to 7.27272727, or just 7.273, okay? That is our value for C. That is our 0. That's the first thing they want us to do. The 0 is 7.273, or approximately. The second yellow box here, describe what this value means in context. Here's the question I'm going to ask you. Can Enrique purchase 7.273 cups of coffee? No. No, he can't. How many cups of coffee can he purchase? Did you say 7? I hope you said 7, because that's how many he can buy. If he's got $20 on his gift card and each cup of coffee costs $2.75, then he can then he can buy 7 cups of coffee. He's going to have some money left over, but he can only purchase 7 cups of coffee. And that is your final answer. Enrique can buy 7 cups of coffee before the card runs out. He will still have, roughly enough for another quarter cup of coffee, but coffee shops don't sell quarter cups of coffee, so he's stuck. He can only buy the 7, and then he's got to either use the rest of the gift card, some of his own money, or lose the gift card in his wallet and forget about it for 5 years like most people do. We can have a full talk about the economics of gift cards another day, but for now, here's how you do these problems. You plug 0 in for whatever letters here in the equation, and these will give you the equation. You do not have to make the equation your own self. Plug 0 in, find the 0, find what the x value is when y is 0, and then describe what it means in context. Give me some kind of a word, a sentence that tells me he can buy 7 cups of coffee, he can go on the ride 4 times, he can fit. There's one that's about like songs in a CD, which makes me laugh because you guys probably haven't even seen a CD since you were babies. But anyway, all the problems are going to work very similar to this, okay? So hop off this video, get your homework done, separate sheet of paper, snap the picture, submit, same old, same old. Guys, I love you. Thanks for watching. We'll talk to you next time.